Hello everyone, welcome back to this online class. Today we are going to look at how to find the ordinary and singular points of an ODE. We are given this question. We are asked to find all the singular points of the following differential equations and hence classify the points into regular or irregular. In part A, we have 2x times x minus 2 squared times d squared y over dx squared plus 3x dy dx plus x minus 2y is equals to 0. In part B, we have 2x squared d squared y over dx squared minus x dy over dx plus x minus 5y is equals to 0. So we need to find the singular point. So let's start with part A. Part A, there are 3 steps to follow. First of all, you can write step 1. You write the ODE in the standardized normal form. Write the ODE in the standardized normal form, or simply in the equivalent normal, in the normal form. In so many words, somebody can use equivalent normalized form, standardized normal form, whichever, but they all speak of normal form. So by normal form, what do we mean? Is simply you make the coefficient. What I mean here is make the coefficient of the highest derivative to be 1. That's what we mean by the normal form of the ODE. So in part A, we need to divide through by 2x times x minus 2 squared. So that equation can now be written as d squared y over dx squared plus 3x over 2x into x minus 2 squared dy dx plus x minus 2 over 2x x minus 2 squared y, that should be equal to 0. So this is the normal form of that ODE. Now, in general, we always let this function, the coefficient of dy dx, this one here, we always call this a function p1 of x. And this other one is called p2 of x. This other one is p2 of x. So I can extract them explicitly so that you can see. So you can just say let p1 of x to be equal to 3x over 2x into x minus 2 squared, and p2 of x be equal to x minus 2 over 2x times x minus 2 squared. You see, you can simplify this. Okay, let's leave them as that one. Now, to find, the other step is to find the singular point. So you can write step 2. Step 2 is now find the singular points. Find the singular points. And how do we find them? Singular points, you simply equate. You see, look at the coefficient of the highest derivative. So in the given ODE, or simply it was 2x into x minus 2 squared. So what I mean is equate the coefficient of the highest derivative in the original ODE. That is before you convert to the normal form. Equate it to 0 and solve for x. That will give you the singular point. So what was the coefficient of the second derivative or the highest derivative in this case? It was 2x into x minus 2, this is squared. Equate this to 0. So from here, it means that this means that either 2x is equals to 0 or x minus 2 squared is equals to 0. From which here we are going to get x is equals to 0, and this other one will give us x is equals to 2. So these are the only singular points. These are the only, let me write, these are the only singular points. These are the only singular points. So it is either x is equals to 0 and x is equals to 2. Those are the singular points. And you see, those are real numbers. And we have so many other real numbers. Any other value of x different from 0 and 2 are called ordinary points. So you can say, you can write a note. On the note, you can write this one. I want us to discuss about ordinary points. So on the note, we can write that, let me write, all the other points, all the other points on the real number line are ordinary points. So that when we combine the set of ordinary points and the set of singular points, we need to get the set of real numbers. So we can say that in this case, it is the set containing, it is the set R, that's the set of all real numbers. Then you subtract the set containing the singular points, which are 0 and 2. So this is the set of ordinary points. So you see the real number line, if it is this kind of a line, which extends from negative infinity to positive infinity, and there is 0 in between, so that this side is 0, let's say 1, 2, etc. This side is -1, -2. So any other number different from 0, because we got 0 and 2, any other number different from 0 and 2, those are ordinary points. I hope that is now clear. the difference between a singular point and an ordinary point. Now that you have found the singular point, let's now see how to classify the points. So you write step 3. Step 3 is classify the singular points. The singular points. So to classify, there are only two types of singular points. One is regular and the other one is irregular. And how do you know that a point is regular or irregular? So what we do, we are going to start with x is equals to 0 and determine whether it is regular or irregular. So you can write this point x is equals to 0. Remember, usually in general, x is equals to x naught. So let x naught be equal to 0. So let, because this is our x naught. So let x naught be equal to 0. Now I need x minus x naught times p1 of x. What is it? It is x minus 0. Our p1 of x, we got 3x over 2x into x minus 2 squared. And when you simplify this, you are going to get, you see this, this is x, this other x will cancel. So it's like we have 3x over x minus 2 squared. So I need to find the limit of that function. So limit as x approaches 0, of course x naught, as x approaches x naught of x minus x naught times p1 of x, what will it be equal to? It is the same as limit as x approaches 0 of what we found here is 3x over 2. There's a 2 here, I left it out. There's a 2. So over 2 into x minus 2 squared. You know how to find the limits? On direct substitution, we are going to get 3 times 0 over 2 into 0 minus 2 squared. And the result is 0. So the limit exists. When you get a number different from infinity, it means the limit exists. So in this case, limit exists. Also, you need to find x minus x naught. So you can just say also x minus x naught times, this is now squared times p2 of x. What will this give us? It is x minus 0, now it is squared, and our p2, let's see what we got as p2. It was x minus 2 over 2x times x minus 2 squared. It was x minus 2 over 2x into x minus 2 squared. So what are you going to get when you simplify? Of course, this will cancel with one of the powers. And here I can see x squared. So this will cancel with one of the x. So that what you get is x over 2 into x minus 2. It's better to simplify before you find the limit. So now let's also get the limit as x approaches x naught of x minus x naught times p2 of x. What will this be equal to? It is the same as limit as x approaches 0 of what we got is x over 2 into x minus 2. And now let's try direct substitution. So on direct substitution, we are going to get 0 over 2, 0 minus 2, and the result again is 0. So now, again, we say that the limit exists. Limit exists. So since both the limit exists, I can conclude here and say since. That should be since both. The key term is both. Both the limits exist. The point x is equals to 0 is irregular. The key term is both the limits must exist for it to be a regular point. So this point here is irregular. Let's test the other point where x is equals to 2. Do the same thing, but now use x is equals to 2. So you can write here point x is equals to 2. So in this case, what is our x naught? Because usually x is equals to x naught, so we are going to say that let x naught be 2. So this is our x naught. So let x naught be equal to 2. Now what do we have? We need, the first one is we need to find x minus x naught times p1 of x. So now x minus x naught times p1 of x is the same as x minus 2. Our p1 was 3x over 2x into x minus 2 squared. If I simplify this, you see here I'm going to get x minus 2 will cancel with one of them. This and this will cancel. We get 3 over 2 into x minus 2. So now find the limit as x approaches 2. So we can now write limit as x approaches x naught of x minus x naught times p1 of x is the same as limit as x approaches, our x naught is 2, x minus, we got, after simplifying, we got 3 over, let me just write what we got here. It was 3 over 2 x minus 2. Direct substitution, can it work? Let's see, direct substitution, we are going to get 3 over 2 into 2 minus 2, which is 3 over 0, and that is infinity. Is there any other way? Because you have found infinity, there's no other way of finding that limit. So the result is infinity, and it's no infinity is not a real number. So what does it mean? That the limit does not exist. Here, it means that the limit doesn't exist. So we don't need to test the other one for P2, x minus x naught squared times P2 of x, because as long as one of the limits does not exist, it means the point is irregular. So you can just say, hence, the point x is equals to 2 is irregular. So when you talk of irregular, you realize that the new functions are not analytic at that point. When you talk of regular, those new functions, what you're calling x minus x naught p1 of x, and x minus x naught squared, remember here there was a square, x minus x naught squared times p2 of x, they must also be analytic at that point, x naught. The limit must exist as x approaches x naught. So that is the distinction, or the difference between regular singular point and irregular singular point. And you should also be able to know the difference between an ordinary point and a regular singular point. Very important. Part B. Part B, look at our ODE. So step one, we need the normal form of the ODE. Let me write in black. So normal form. So how will it look like? The ODE in part B. Let me take you back to that ODE. It is this one. So remember we are done with part A. Now we are doing part B. So it is this coefficient that you need to divide through by, because you need to make the coefficient of d squared over dx squared be equal to 1. So I'm going to divide through by 2x squared. So this is what I'm going to get. If you divide that equation by 2x squared, you're going to get d squared y over dx squared. The other one is minus x over 2x squared dy dx plus x minus 5 over 2x squared y is equals to 0. So that's the normal form, and from here you can be able to find your functions p1 of x and p2 of x. So let me write this here so that I can also take it together with that function. So this one here is our p1 of x, and this other one is our p2 of x. So the second step is to find the singular point. So you can write here step 2. Step 2 is now about finding the singular points. So I told you what to do. Equate the coefficient of the highest derivative to 0 and solve for x. So we'll write 2x squared is equals to 0. So what will be x in this case? When you divide, you get x is equals to 0. That's the only singular point. There's no other singular point. All the other points are ordinary points. So you can say this is the only singular point. This is the only singular points. Singular point of the ODE, the given ODE. So it means any other value of x on the real number line is an ordinary point. So you can just write a note here. Let's have a note NB that all the other points on the real number line are ordinary points. So the set of ordinary points is this one. you take, so you can just write the set of ordinary points. Of course, for this particular ODE, ordinary points is, it is the entire real number line, which is written as that one, then minus the set containing that singular point, which we have found to be x is equals to 0. Now that we know the singular point, let's see how to classify the point. So step 3, classification. So in this case, our x naught is 0, because this is our x naught. So you can say here that let x naught be equal to 0. So what I need is x minus x naught times p1 of x. What will it give us? It is x minus 0. Our p1 of x, we got negative x over 2x squared. If you simplify, I'll get x squared in the numerator, another x squared in the denominator. So that's negative 1 over 2, because you know how to simplify. So you need now to find the limit as x approaches x naught of x minus x naught times p1 of x. So that is the same as limit as x approaches 0 of what we got is negative 1 over 2. And you see, limit of a constant is the same constant. So that's negative 1 over 2. That means the limit exists. Limit exists. Let's also work out the other functions. We can write also. We now need x minus x naught. Now you square it. Don't forget to square when you're multiplying it by p2 of x. So this is the same as x minus 0 and you square it times our p2 was x minus 5 over 2x squared. And so that will mean that we have x minus 5 over 2 when you simplify. And so now take limit as x approaches x naught, which is 0 in this case. So we now have limit as x approaches x naught of x minus x naught squared times p2 of x. It is the same as limit as x approaches 0 of x minus 5 over 2. And so direct substitution will give us 0 minus 5 over 2. And so that's negative 5 over 2. Again, that's a real number. So again, you say the limit exists. So what can you say? So you can just conclude and say that since both, the key term is both the limits exist, the point x is equals to 0 is irregular. It's a regular singular point. So the key term is that both the limits must exist. What is the interpretation when we say the limit exists? It means that this function and this function are analytic at x is equals to x naught. That's what it means. So that's how to find the singular points, ordinary points, and also classify the singular points into regular and irregular. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okage or Prof. Francis Okage, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving singular points and ordinary points of an ordinary differential equation. Bye-bye.